Okay, so we're going to take a look at an application of linear systems of equations. And in particular in this video, we're going to look at cost, revenue, and profit functions that are linear. So the first thing I want to do is talk about cost, revenue, and profit, just the very basics. So cost is money spent by a business, okay? So this might be to buy supplies, to pay workers, whatever it may be. Money spent by a business is the cost. Now revenue is probably the most confused aspect of this video. So revenue is not the same thing as profit. Revenue is money brought in. Money brought in by the business, okay? So every source of income is revenue. That's not profit necessarily unless they don't have any cost, right? So we got to be careful here. So what is profit? You could probably figure out what profit is based on cost and revenue. Profit is literally you take how much money is brought in. You take how much money is brought in and you subtract the money spent. Okay? You subtract the money spent. So oftentimes maybe profit is written as profit equals the money brought in. Well, that's revenue minus the money spent is cost. And so all you have to do is subtract to see how much is left over. Now, sometimes the cost is more than the revenue. That's when a company's losing money, right? That would mean if you subtracted this, if your cost is bigger, you're going to get a negative number. So that means you're currently not profitable, and that can happen. If your profit is zero, that's a break even, right? Your revenue and your costs are equal. You're breaking even at that point. So those are the basic concepts behind this video. Now let's get into a particular example using a linear system of equations or functions and how they go together. So bear with me. Actually, here's what I'll do. I'm going to write this long word problem. So I'm going to pause the video while I do that, and then I'll come back and read it in case you do want to copy it. You can pause and copy it down if you're taking notes. Okay, so here we go. We have the small book here, which is necessary to understand the problem. So Todd bought a truck and would like to start a lawn mowing business. He has to buy equipment to get started, and that's going to cost him about $500. And then he's going to have to pay, every time he mows the lawn, he's going to have to buy gas, he's going to have to travel, he's going to have to buy a weed eater line, sharpen blades, replace blades, things like that. So he figures on average over a long-term period, it's going to cost him about $5 per lawn to pay for all those things. And then his plan is to mow subdivision lots at $20 per lawn. So we get the idea of what's going on here. He's wanting to do a bit of cost analysis before he gets this business going to kind of plan ahead for what to expect money-wise. So the first thing we want to look at, or that Todd may want to look at, is his cost. So let's, part A, let's determine a formula for his cost, C of x. We'll call it a function c with input x, where x is the number, of lawns mowed, okay? So basically, if he mows x lawns, x number of lawns, how much is that going to cost him? So C of x equals, now no matter how many lawns he mows, just to get started is going to be $500. So his cost is going to be $500 no matter what. That's independent of how many lawns he mows. But then how much cost does he have for every lawn? Well, his maintenance and fuel and all of that's going to cost him about $5 for every lawn. And if he mows X lawns, then that's going to cost him 5 times X dollars. And so his total cost for mowing X lawns is going to be his initial cost, which in this case is $500, plus his cost per lawn, right? So this is a fixed number. This number changes. If he mows more lawns, it's going to cost him more money. So this is our cost function. All right, so I'll remember that. 500 plus 5x is his cost function. And of course, that's in dollars, right? So, so here, C of x is in dollars. That might be important to note. Okay, so probably what you can guess that part B is going to ask is the same thing, but we want to know the formula for his revenue. Determine a formula for his revenue. So this will be part B. Determine a formula for his revenue. And you can probably guess what the function is going to be called, R of x. And we don't need to specify what x is now because we already have. X is the number of lawns. So now we're talking about how much money does he bring in when he mows x lawns. Well, the only money he takes in is every time he mows a lawn, he gets paid. Nobody's giving him money up front to get started in the business, none of that. There's no seed money. The only income is he gets $20 per lawn. So this formula is pretty simple. There is no initial revenue to start with. He just makes $20 for every lawn, and there's X lawns. So we multiply 20 times X, $20 times X will tell us how much money he makes when he mows X lawns. And that's it. That's our revenue function. And of course, this is in dollars, just to be clear, okay? So now we have his cost function and his revenue function. So something we might be interested in, you know, when you start a business, you want to know, when am I going to start making money? Okay? So initially, because of this initial $500 cost, he's losing money. How long is it going to take this $20 per lawn to catch up to his cost of $500 plus his $5 for every lawn? So that's an interesting question, and that's what we call the break-even point. So now, let me erase the problem. We've got the problem down. We've got his cost function and his revenue function. So I'll write those up here so we have those. So the cost function was 500 plus 5x. The revenue function was 20 times x, okay? And now let's look at question C. So question C asks to determine the break-even point. Determine the break-even point. So the break-even point is when the cost and the revenue are equal. And sometimes this is even called equilibrium. They're balanced, right? So equilibrium or break-even point, the cost and the revenue are equal. So in other words, we have the system of two equations. We want to know when they're equal. Graphically, remember, that means when do these two lines, because these are linear equations, when do these two lines cross? Okay, but we want to know when cost equals revenue, right? So that's break even here is when cost equals revenue. If you're doing like a supply and demand problem, this might be called equilibrium, and you'd want to know when the supply equals the demand, and you'd set those two equal and solve, okay? But this is cost and revenue, so we call it break-even point. All right, so now solving this equation, I'll subtract 5x over to get 15x equals 500. And then I'll divide both sides by 15. And it looks like that is 33 and a third. Let's see. Divide by 5, that'd be 100 over 3. Yeah, 33 and a third. So in other words, what this means is if he mows, remember what x represents. X is the number of lawns. So this says if he mows 33 and 1/3, which is not possible, by the way. You don't get paid for 1/3 of a lawn. But if he mows 33 and 1/3 lawns, he will break even. That is the precise point with these two models where his cost and his revenue will equal each other. So meaning, if he mows 33 lawns, his cost is still going to be more than his revenue. His revenue wouldn't have caught up yet. But when he mows his 34th lawn, that's when he's going to pass that break-even point and start making money. He'll be profitable at that point. I apologize for the lack of straight lines here. Okay, but that's a great question. The break-even point is 33 1/3 lawns. Okay? All right, now, let's take a look at the graph of these two functions and how the break-even point shows its pertinence to this problem. So part D, graph C of x and R of x on the same plane. And I think it's going to be a good idea here to use graph paper. So I'm going to pause the video while I get my graph paper on the board, and then I'll come right back. Okay, so I've got my graph paper here, and we need to probably think of these functions before we set up our grid with the scale. Okay, so you can graph these a couple different ways. You could think of them in slope-intercept form, like y equals mx plus b. So this would have a y-intercept of 500 and a slope of 5. This guy is mx plus 0, so the y-intercept would be 0, and the slope would be 20. So this guy's going to grow much faster. The slope will be 20, but it's going to have a smaller starting point at 0, whereas this guy has a starting point at 500. So the best thing I'm going to do is I could use my slope. However, because of the scale I'm going to use here, the slope's going to be hard to use. So instead of using slope, I'm just going to use 2 points to graph each line. All right, so if we look at C of x, let's use a different color here. If we look at C of x, we could have x and y. And let's use 0, of course. If I plug in 0 for x, then y is just 500. That's the y-intercept. And then let's look at maybe, I don't know, well, we know the break-even point, remember, was x equals 33 1/3. We want to at least show that x value on our graph, so let's go past that and maybe go to 50. Let's go to x equals 50. So if x is 50, 5 times 50 is 250, plus 500 is 750, okay? So we kind of understand the types of numbers we're going to need on our graph for this function. Then let's look at the R of x function and do the same kind of thing. In fact, let's use the same two x values, 0 and 50. If x is 0, 20 times 0 is 0. That makes sense. That means if he mows 0 lawns, his revenue is going to be 0. Okay? Then, if we plug in 50, we get 20 times 50, which is 1,000. So my y-axis is going to have to go from 0 to 1,000, and my x-axis is going to have to go from 0 to 50. So let's set up the grid now. So I know I only need the first quadrant of the plane. So here we go. This axis will be number of lawns. This will be our x-axis, right? And then our y-axis will be the dollars. It's going to represent cost and revenue, so I'm just going to label it as dollars. Okay. Now the x-axis has to go from 0 to 50. So I will set it up in, let's say, tens, okay? So here's 0, let's call this 10, 20, 30, 40, 50. So there's 50, 60, 70, 80, 90, we can keep going. So 30's right here. We know the break-even point is 33 1/3. So somewhere past 30 should be our break-even point when we graph these two functions. All right, so I've got the x-axis set up. The y-axis has to go from 0 to 1,000. So let's see if I've got enough grid marks here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. I'll go by 100. So I'll call this 1,000. And so here's 100, 200, 300, 400. There's 500, 600, 700, 800, 900, 1,000. Okay? All right. Now let's graph the functions. We have 2 points for each. I'll use blue for the cost function. The cost function goes through the point 0, 500, which is right here. And it goes through the point 50, 750. So here's 50. There's 500, 600, 700. 750 is right there. So let's graph that line using a straight edge. So something like this. There we go. So this is the cost function, c of x. Let's do the same thing for the revenue function using the 2 points we have for it. The revenue function goes through 0, 0. And at 50, it goes through 1,000, which is up here. Okay? So that's our revenue function, r of x. So just let's discuss this graph. I mean, let's look at what it's telling us, do some analysis here. This is very good for Todd. He's got some analysis. He can sort of project what's going to happen in the future. So we can kind of see that, let's look at the cost function first. We can see that initially he's having to spend $500. And he just has to spend $5 per lawn after that. So that's that slope, 5 over 1. So the slope is kind of small for this graph. His cost doesn't go up much past that initial cost of 500. His revenue starts at 0. He doesn't have any income to start with. But as he mows lawns and makes $20 per lawn, that slope is a lot steeper than the cost function, which is a good thing, right? So this graph will overtake the cost function eventually. In fact, it's going to overtake it right here at the break-even point. Use the wrong marker. Right here at the break-even point of 33 1/3, right? There's our break-even point at 33 1/3. And we could even figure out what the cost and revenue are there, right? We could figure out the y value, which appears to be a little bit less than 700 according to the graph. So if I wanted to know the actual cost and revenue here, I could plug the x value of 33 1/3 in to either one of these functions. Okay? So that's how that plays out in the graph. And so before he breaks even, you can see that his cost is more than his revenue. So he's losing money. And then once he reaches his break-even point, he's not losing money anymore. He's broken even. And after that, his revenue passes his cost and he's making money. So you can see that very visually on this graph. Okay? So that's a detailed analysis of this cost and revenue. Let's look at his profit. Okay, I put the graph paper away, and I think we are on part, let's see, E now. Part E. Let's determine R of 20 minus C of 20. And let's explain its meaning. Explain the meaning. So all that's going on here is R of 20. R of 20 is the revenue his income he's made at the point where he's mowed 20 lawns. Income after mowing 20 lawns, right? And so how do we calculate that? We use the formula here where x is 20. So that's 20 times 20 lawns, which is $400 in revenue. Okay? So we've got the R of 20 figured out. Now let's do the C of 20. So C of 20 is his cost after mowing 20 lawns. His cost after mowing 20 lawns, of course. And so to figure that out, we use the cost formula, which it tells us to plug 20 in for X. So we have 500 plus 5 times 20. 5 times 20 is 100, plus 500 is $600. Okay? So now we know his cost for mowing 20 lawns. So now let's answer the question. So R of 20 minus C of 20 equals 400 minus 600, which is negative $200. Okay? And what is its meaning? So the meaning is, well, we had $400 in revenue, $600 in cost. We subtracted those and got negative $200. That means if he only mows 20 lawns, he's going to lose $200. He's not going to be profitable, okay? So that his profit at this point is negative $200. Not a good thing. So he needs to mow more than 20 lawns if he's looking to make money. All right? So that's an introduction to profit. Now let's be more specific here and look at, or more general, let's say, and look at part F, which is to finally determine a formula for his profit. Right? Determine a formula for his profit, and we'll call it P of X. His profit for mowing X lawns. So, if you recall from earlier in the video, we established that profit is revenue, all of his income, minus all of his cost. And we have formulas for those. So all we do is we take his revenue minus his cost. So revenue is 20x. His cost is 500 plus 5x. And we have to subtract those algebraically. So we don't really need the 20x in parentheses since there's nothing outside being multiplied by it. So I'll drop those parentheses. And here I have to distribute my negative. So I get minus 500 minus 5x. And I can combine like terms at this point. 20x minus 5x is 15x. 15x minus 500. So here is the profit formula for him. Here's this profit formula if he mows X lawns. So just to put a handle on this, if he mows 0 lawns, if we plug in 0 for X, his profit will be negative 500. He's going to lose $500 because that's how much he spent to get started. Okay, so that makes sense. If we plug in 33 1/3 for X, how much should his profit be? Remember, that was the break-even point. If we plug in 33 1/3 for X, we should get a profit of 0 because that's the point where the cost and revenue are equal, remember? Okay, so we can now use this function to calculate his profit in various circumstances. So let me add the profit function up here to our list so I can reference it. 15x minus 500. Okay, and again, remember for all of these formulas, X is the number of lawns, and then all the formulas output dollars as well. Okay, last part. Let's see. That was part F. Let's look at part G. And this is the end of the video, okay? So determine P of 50. Explain its meaning, okay? So let's first figure out what P of 50 is. So P of 50 means plug 50 into the profit function. which is over here. So we have 15 times 50 minus 500, okay? 15 times 50 minus 500. So that's 750 minus 500. Just do all that at once. 750 minus 500 is 250. So that's P of 50. That's the first part of the question. P of 50 equals 250. Now, what is its meaning? I'm not going to write it down. You can write it down if you're taking notes. This means that his profit for mowing 50 lawns is positive $250. And that makes sense. When he mows $50, he's gone past his break-even point, so he should be making money. And we, in fact, get a positive number here. So his profit when he mows 50 lawns is $250. Okay, hope this helps you with seeing an application of systems of equations. Here they were systems of linear equations in function context. We looked at break-even point, graphing, lots of things here that we analyzed. I hope it helps. Good luck to you.